Hello, everyone. I have your notes today for 3-8. The first part is just putting things in order from least to greatest. You can list them out. I put 1 for the least and 5 for the greatest on mine because I didn't feel like they gave me a lot of space here. I had to do some thinking and some number crunching on a few of these. This one I knew was big. I knew that it's a 1 with 6 zeros. That's 10. And then this is 100, obviously. And then these two I had to do some thinking about. 2 to the 5th, well, let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 6 is 64, 128. I really had to go to my calculator. 2 to the 8th is 256, so let's try 2 to the 7th. 2 to the 7th is 128. I think I already just said that. So it's like 6 point something. I don't care what it is. And then 2 to the 10th, I actually typed that into my calculator as well, 1024. Okay, so when I put these in order, the smallest one is 10. I'm a liar. The smallest one is 6, then 10, then 100, then 1024, and then this big guy. Okay, now for these, I get 1 over 2, which is 1/2. This will be negative 10. This will be a negative exponent. 2 to the negative third is 1/8. That's just 0. And this will be negative 2. So which one of these is the smallest? Negative 10 is the smallest, then negative 3, then negative 2, 0, then 1/2. 2 to the 0 is 1, square root of 25 is 5, 2 to the third is 8, 2 times x to the 0. Well, x to the 0, if x isn't 0, is 1. 2 times 1 is 2. That was kind of a weird one. And this would be 1 over 2 to the 1/2, which is 1 over the square root of 2, which is a fraction. So which one of these is the smallest? It looks like this is the smallest. And then we'd go to 1, 2, 3, and then 5. Okay, 3 to what power is 3 to the third? If you remember, these kind of just cancel out and you would get 3. 5 to, all these are the same rules here. Okay, so the smallest one is negative 2, then negative 1, and then 0, and then these guys are tied for the last spot. Okay, so that's the top part, just putting things in order from smallest to biggest. And here we're going to do some comparing. I think this is kind of a cool section. So you have the F graph, and I'm actually going to kind of highlight this. This might help me a little bit. F graph I'm going to go with is yellow. And then G will be the black one. So they want to know at 0, the value of F. At 0, the value of F is up here at 2. When X equals 0, F equals 2. So this guy is 2. G of 0, you can tell, is down here at 0. So F is above G at the 0 marker. At 2, which would be here, you can't even quite tell. You can't tell which one the values are, but you don't need to know because I need you to think. Look at the rate of change here. This rate of change is slowing. This rate of change is faster. At 2, this yellow graph is going to be ahead, which is the F graph. At negative 1, you can see. At negative 1, the black graph is ahead of the yellow graph. So negative 1 is the G graph is greater. Now here you're comparing two different values, which is strange. So F of 1 would be 0. G of negative 1 looks like it's up at 1, so G is ahead of that one. At 5, once again, 5 is not even on my chart, but use what we can tell about these rates of change. This one is a slower rate of change. This one is much steeper. That F graph has to be ahead of it. And at negative 2, you can see the G graph, but you cannot see the F graph, but it doesn't matter because which one is going to be greater? G is for sure going to be greater than that. Okay, this is getting us warmed up to this idea of M behavior, which will come up soon. This is just like the examples in the notes. They're telling you one root and you're going to find the others. You could use your calculator to help you with this, or you could use division. If you have a root of 5, that means x minus 5 is a factor. You could put 5 in the box and the coefficients beside it. You will get a remainder of 0. If it's a factor, it divides evenly. So you drop the 1 in party, you multiply, you add, you multiply, you add, you multiply. There's that remainder of 0 that I knew. This is my number x squared. So then the other factor would be x squared minus 8x plus 12, but that does factor further. So you have x minus 5, and this will be a minus 6 and a minus 2. So you can get 6 and 2 as the other roots. Now, you could have typed this into your graphing calculator. X cubed minus 13x squared. X cubed minus 13x squared plus 52x minus 60 plus 52x. I don't know what I'm doing here with all this. All right. And if you graph it, you can kind of see them here. You could do second calculate 0 if you wanted to find those other spots. This one will give me 2. But I like to use the table a lot as well. And you can go to second table, and there's 2. These are not going in the right direction. There's the other 2. You see them? 5 and 6. So 2, 5, and 6, you can go that way as well. Okay, so let's try this one. It might be quicker to divide. It might be quicker to use your calculator. That is up to you. If x equals negative 6 is a 0, then x plus 6 is a factor. I can put negative 6 in the box. 1, 6, negative 11, and negative 66. I'm going to get 0 as a remainder here. Oh, I got 0 in the middle here, which sometimes adds confusion to some of you. Remember, we drop it and then we multiply, we add, we multiply, we add, we multiply. There's a remainder of 0. So my other factor is x squared minus 11. Remainder, number, x squared. This is considered factored over the integers. This is good enough, but I need to find those other zeros. Your calculator could not help you with this one, guys. I'll show you what it would look like. If you solve it, if you set that equal to 0 and solve, you have x squared equals 11, and the other 2 roots are plus and minus the square root of 11. Just a reminder, I don't really want to type that all the way in, but just a reminder, if you would have done second calculate 0, you would see these, but it would give you a really nasty decimal that you wouldn't recognize. So you would have to do this one by hand to get the exact answers. Okay, on this one, if x equals negative 3 is a root, then x plus 3 is a factor. I can put that negative 3 in the box because we always put the opposite of the constant in here, or you put the 0 in the box if you want to think of it that way. 1, 17, 92, and 150. Drop the 1 and party. You multiply, you add, you multiply, you add, and you multiply, and you add. Okay, so there's the 0, remainder number x squared. And I don't know if this factors or not. X squared plus 14x plus 50. 25 and 2, 5 and 10. I don't think it does. So I do believe this is factored over the integers. So to find the last 2 zeros, you would have to set this factor equal to 0 and quadratic formula. Or I'm going to actually complete the square. X plus 7 squared is 49. I just need one more to get to 50. This one's actually going to have imaginary zeros. If I was to graph it, I would see only one x-intercept at negative 3. The rest I couldn't even see. So you actually would have to do this by hand. X plus 7 squared is negative 1. Square root both sides. There's an I, plus or minus I, and then subtract 7 from both of them. So negative 7 plus I and negative 7 minus I as those last 2. Okay, now 14, I would use my calculator on this one. First of all, if it says x equals the square root of 2, then you can immediately write the opposite, negative square root of 2, because irrational roots and imaginary roots always come in conjugate pairs. I don't know why that didn't work, but it's not working. Okay, so right up here. Oh my gosh. Shake my pen. All right, there it goes. Okay, now if you type this in, hopefully you can find some real ones and we don't have to do long division, because your other option now would be to take x plus square root of 2. I don't know what's happening with my pen. And x minus, oh my gosh, square root of 2. Double distribute to get the first nice factor, and that's going to be an x squared plus square root of 2x minus square root of 2x. Those will cancel, and it'll be minus square root of 4, which is minus 2. So the first factor is x squared minus 2. If you divided that out, you're going to get have to do long division. A lot of you don't like long division. So if I type this in to my calculator, x fourth minus 6x cubed, x fourth minus 6x cubed plus 3x squared plus 12x. I think it's a minus 10. Yep, okay. And you graph this. Yeah. Okay, these are real close. You might have to even zoom in a little bit. Okay, so it does go up. If you go to your table and you're looking for real ones, which is what I like to do, and you're like, ooh, thank God, there's one at 1 and there's one at 5. So 1 and 5 are my other two nice ones here. You know, negative square root of 2 is 1. X equals 1 and x equals 5. That's all I needed. All I needed was 4. So you can have your x minus 1, your x minus 5, and then we already multiplied that out, and we got an x squared minus 2. And that's your factor 4. Okay, I think the video is probably getting long. I'm going to stop here and do the Go video on our next one.